All right, number 5, we again want to approximate this number using a calculator. Okay, so E is exponential. It's in yellow above the division on my calculator. If I hit second and then E, it's kind of like a irrational number like pi. If I hit enter, you can see what E is. Now there's more digits, but the calculator only shows you so many. We're going to raise E to the 2.6 power. So I'm going to do that again. Second, the division sign to get E, we're going to raise it to 2.6. 2.6. And we're going to round that to 3 decimal places. All right, we get 13.463. All right, 3 is what we're rounding. The 7 says round it up, so 13.464. All right, number 6. This one we want to tell or determine whether the table is linear, exponential, or neither. Okay, so we're either looking for a constant rate of change or a constant ratio when we divide. So in this table, can I see the whole thing at once? Okay, so let's look down the X column, and then we'll look down the Y column. I'm just going to put Y instead of f of x. It's the same. We have -1, 0, 1, 2, and 3. And then over here we have 1/3, and then 1, and then 3, and then 9, and then 27. All right, so we can see a difference of 1 every term here. So we just add 1, add 1, add 1, add 1. Here, if we were subtracting, this would give me a difference of 2/3. And then if I subtract these, this will give me a difference of 2. So you always go furthest down to the previous one. So 3 minus 1, 1 minus this. 9 minus 3 will give me 6, and this will give me 18. Okay, so we can see it is not a constant rate of change. The change in y over the change in x is not the same. So what we want to do now is try to divide. So we're going to do 1 divided by 1/3. See what we get. And then we're going to do 3 divided by 1 and see what we get. 9 divided by 3 and see what we get. And then 27 divided by 9 and see what we get. So it's not linear. And my 27 divided by 9 is running off. So when you do the fraction, keep, change, flip. Okay, so this will be 1 times, flip this, 3 over 1. And that gives me 3. When I do 3 divided by 1, we just get 3. So it looks good to be exponential. We get a constant rate of change. 9 divided by 3, 3. And 27 divided by 9, we get 3. So since we get a constant ratio, that means we have exponential. So the function is exponential. And then we can say the exponential function models, since this is my rate of change, we would do 3, and it's always to the x power. Okay, just on the basic form. So whatever you get as that constant ratio, that's what your base is when exponential. So this function is a exponential modeled after 3 raised to the x power. Raised to the power of x.